Let's take a look at this problem. We got cosecant theta minus 2, cotangent theta plus 1 is equal to 0. And I want to find all of our answers between 0 and 2 pi. This is already factored, so I can use the zero factor property. It says if you got 0 on one side and you factored the other side, you set each factor equal to 0. So I'll set cosecant theta minus 2 equal to 0, and I'll set cotangent theta plus 1 equal to 0. Now to solve this, I get cosecant theta is equal to 2. Now sometimes it's easier for us to put these in terms of sine and cosine. Remember, cosecant is 1 over sine, and 2 I can write as 2 over 1. You can always create a fraction by putting it over 1. Now if you have a single fraction equal to a single fraction, you can flip both of them. Just take the reciprocal of them. So you have sine theta over 1 is equal to 1/2, or just simply sine theta is equal to 1/2. Okay, we got pi over 6 here, which is square root of 3 over 2 and 1/2. And we have 5 pi over 6, which is negative square root of 3 over 2 and 1/2. Now we're looking at our unit circle where sine is equal to 1/2. Remember, sine is our y part of our point. Well, here it's equal to 1/2, and here it's equal to 1/2. So theta is going to equal to pi over 6 and 5 pi over 6. Maybe. We'll come back to that. Okay, we're going to set cotangent theta. And we want to get it by itself, so I take the 1 over, it becomes a negative 1. And we're looking where cotangent is equal to negative 1. Cotangent, remember, is x over y. I could put this in terms of sine and cosine, but it might be kind of hard to figure out what our answer is when we do that. But if we remember x over y, and it's equal to positive 1, well, we got pi over 4 here, which is square root of 2 over 2, square root of 2 over 2. We have 3 pi over 4, which is negative square root of 2 over 2 and positive square root of 2 over 2. We have, 3, 4, 5 pi over 4, which is negative square root of 2 over 2 and negative square root of 2 over 2. And we have 7 pi over 4, which is positive square root of 2 over 2 and negative square root of 2 over 2. X over y. Well, if I go to pi over 4 here, x over y, I'd have square root of 2 over 2 over square root of 2 over 2, which would give us a positive 1. So that doesn't work. Now 3 pi over 4, x over y, so I'd have negative square root of 2 over 2 over positive square root of 2 over 2, which would give us negative 1. So theta is equal to 3 pi over 4. Now down here, cotangent is x over y, so negative square root of 2 over 2 over negative square root of 2 over 2 is a positive 1, and we're looking for negative 1. And 7 pi over 4. X over y, square root of 2 over 2 over negative square root of 2 over 2 gives us a negative 1. So that would tell us that 7 pi over 4 is another one of our answers. Now we want to make sure that if we plug these back in, it doesn't cause anything to be invalid. But if I put in pi over 6, cotangent's defined at. 5 pi over 6, cotangent's defined at. So that didn't cause us any problems. If I were to plug in 3 pi over 4 and 7 pi over 4, well, cosecant is defined at both those places, so those would be our answers.